Okay, so quadratic relations, putting it all together. So this is putting all of the steps together. Our step pattern that we've looked at is always over 1, 2, and 3, and then up 1, up 4, up 9. And this always starts at the vertex. Okay, so when we're looking at a quadratic, we always start at the vertex. Now, the A value stretches or compresses. So stretch, compress, or reflect the graph. Okay, so, whoops. So when we're looking at the A value, all we have to do is we always have to multiply our up values by the A. Okay, so A is always going to multiply our up values, and that's going to take care of the A value. The H moves it left and right. And remember, if it said like x minus 3, we'd move it to x plus 3. If it said x plus 6, we would move it left 6, we move it to the negative 6. And the K value moves it up or down. Okay, and this is moving our starting point so that we can do our step pattern. Okay, so looking at this next graph, our vertex is right here. It's always the turning point. Okay, so right in the middle of the graph is the vertex. And the vertex in this case is 5 on the x and 6. Okay, the axis of symmetry is that dotted red line. That is going to be x equals 5. It's the x value of the vertex. It's opening down because the graph is facing down. If it's opening down, that means that this vertex value is a maximum. It's the highest value we can get. Okay, it's a maximum of 6 because it's the y value of the vertex. Okay, the y-intercept in this case, we don't know the y-intercept. We can actually find it, but in this case, it's not given, so we'll leave that out. The x-intercepts are right here and right here. So our x-intercept, or our zeros, are about 3 and 6.7, let's call it. Okay. Now, the A value, so we didn't find the y-intercept because it wasn't on the graph. The A value, remember the A value is always going up or down by what it should have done and what it is doing. So we take what it is doing, it's going over 1, down 2. So we're going to divide that by what it should do. It should go over 1, down 1. Up 1. So then our A value is negative 2. Our H value, we've moved to the right 6. So 5. So our H value is 5. Our K value, we've moved up 6. So our K value is 6. So our equation would be y equals negative 2. Now remember, x minus 5, because we've moved to the right 5, squared plus 6. Okay, I probably won't ask you the h and the k value like this. I'll probably just ask you to write the equation, because I do think that the h value is a little bit confusing with the negative, but there's our equation. Okay, looking at this one. This one's a little bit easier to see our y-intercept because it's actually on the graph. Okay, so when we're looking at this one, the vertex, still right there, the turning point. So the vertex here is 3 and negative 7. Okay, so 3, negative 7. That means the axis of symmetry is x equals 3 because it's always the same as the vertex. The direction of the opening is up because our graph is opening up. That means that this value right here is a minimum. It's the lowest the graph can get. So that's a minimum, and it's a minimum of -7. The graph can go all the way down to -7. Now the y-intercept here is about -2.5. And our x-intercepts, or zeros, again, the zeros are the same as the x-intercepts, are negative about 0.8 and 6.8, we'll say. Okay, now this case, I'm going to just change colors so we can see it. For the a value, if we go over 1 up, we can't really tell what it's doing. So we're going to go over 2. Normally we would go up 4, but here we're going up 2. So we're going to do 2 divided by 4. That makes our a value 0.5, or 1/2. Okay, you can write it as either way, I don't really care, but if you do 2 divided by 4, you get 0.5. Our h value, we've moved 3 over, and our k value, we've moved down 7. So our equation would be y equals our a value, 0.5, bracket, x minus 3, squared, it's minus because we're moving to the right, minus 7. Okay, the equation is always y equals a, x minus h, squared plus k. All right. Next question. It says, graph each of these onto the graph provided in 2 separate colors. Okay, so the first thing we're looking at is our starting points. So we'll do this first graph. I'll do that one in red. Okay. So our starting point here is going to be -3, because we always go the opposite way. So -3 and +4. So right there is your starting point. Now we need to make our over and up chart. So normally we'd go over 1, up 1, over 2, up 4. So we'll just do 1. But we always have to times that by our a value. And here our a value is -1. So what we're going to do is we're going to go over 1, down 1, over 2, down 4. So now we've got our new step pattern. So over 1, down 1, over 2, down 4. Now we have to do it on the other side. Over 1, down 1, over 2, down 4. And then all we have to do, connect our dots in a nice round fashion. Our vertex is right there, -3 and 4. Okay, that's our starting point. Our direction of our opening is down. Okay, the axis of symmetry is always the x value from your vertex. X equals -3. The zeros in this case are easy to see. It's -1 and negative, what is that, 5? The y-intercept, if we went over 1 more, so we'll do the whole step pattern here, 1, 4, and then the next one's 9, 3 squared, times it by -1, get -9. So we're going to go over 3, down 9, we go right down to there, and that's actually going to give us our y-intercept of -5. Optimal value, we're going to just change that. Optimal value is max or min. So in this case, it's a maximum, okay, because it's the top of the graph. So that's the maximum value. It's the highest it can get, and it's a maximum value of 4. Okay, let's try the next one. We'll do the next one in blue. So our starting point is going to be 3 to the right and down 8. So we're going to go 3 to the right. We're going to go down 8. So 1, 2, 3, down 8, right there. Okay, now our step pattern for this one. Oh, so we've got over and up. So 1, 2, 3, 1, 4, 9. We're timesing it by our a value, times 2, times 2, times 2. So that becomes 2, that becomes 8, and that becomes 18. That one might be too big to get on the graph, but that's okay. So now we're going to go over 1, up 2. Over 2, up 8. And over 3, up 18. So we can't get that one on the graph. So over 2, or over 1, up 2. Over 2, up 8. And this one just for the y-intercept. If I went up 18, I'd go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm at 8, 17, 18. So I'm at 10 there. Okay, it's not on the graph. That's okay. We can just quickly fill it in a little bit. Okay, so then our vertex down at the bottom, we've got 3 and -8. This is going up. The axis of symmetry is x equals 3. The x-intercepts are 1 and 5. The y-intercept, we just said, was 10. And this one is a minimum of -8. All right. Okay, last page here. So match the following graphs. So just to kind of go over this last one, all I did here was find my starting point and then use my over and up chart. Okay, and I just changed my over and up chart by multiplying by a, multiplying what's in front of the brackets. All right, so looking at this, this is actually quite easy if you eliminate the ones that are simple. So first, only one of these 3 graphs, A, B, and C, so we're looking at the graphs over here, only one of them goes down. Okay, so that means that the middle graph here has to be C, because it's the only one that goes down. Okay, so now I just have 2 that are going up. The red and the blue graph are going up. They're starting up. Okay, now there's 2 different ways to look at it here. One is starting on the right and one starting on the left of the y-axis, but also one's facing up and one's facing down. So whichever one's facing down has to have a -a value. Okay, so that would mean that B goes here